In this video, I'm building a cyber-physical stay unlocked only if you're present mechanism using an ESP32-CAM and a small Windows app. The computer displays a big QR code that changes every 5 seconds. The camera keeps watching that screen and the system stays in a safe state only while the camera can continuously read and verify those changing codes. If the camera misses the code 3 times in a row, the display turns red and the computer attempts to lock the user session to protect the system. The QR is not just a random picture, it's a short sign challenge that proves it was generated by my trusted app. Each code contains a time step based on the current time, a tiny random value, and a short cryptographic stamp computed from a shared secret known only to the app and the verifier. Because of that secret stamp, an attacker can't simply copy an old code or print a fake one and keep the system unlocked. And because the code changes frequently, any captured code expires quickly. Hardware-wise, the ESP32-CAM is already running a basic camera streaming firmware, so it is continuously sending live video over the local network, and I physically aim it at my laptop screen where the QR overlay appears. The overlay window is always on top, smaller in size and slightly see-through so it can sit in a corner while I'm working. Software-wise, the Windows app has 3 jobs. First, generate a new short QR token every 5 seconds and render it large with strong contrast so it can be scanned from a distance. Second, read the live camera video feed and try to decode whatever QR the camera is currently seeing. And third, keep a miss counter where each 5-second cycle must produce at least one valid scan. Otherwise, that cycle counts as a miss.